All right, guys. So yesterday technically we explained what is binomial expansion and what is your binomial theorem and how you're supposed to get to terms and stuff of that sort. Today we're going to see how to utilize the binomial theorem, and we're going to see what sort of questions the examiner is going to ask us. All right. So we're going to go through with them. Okay. So the first thing that is going to happen now is that let's try to. So the binomial theorem, you guys were introduced to it in our previous class. And in today's class, what we're simply going to do is that we're going to see what is going to be asked of you or how you're going to use the binomial theorem. So first off, the binomial theorem states that for a binomial expression being expanded through a power which we don't know, you're going to use NCR. And by the way, guys, do not confuse my N with my R. And inside the bracket, it's going to be A N minus R. And on the outside, it is going to be B raised to the power R. Clear? That is your binomial theorem. We saw this yesterday. Now, what type of questions can come in the exam, or what can the examiner ask you to solve for? First thing that he is going to, usually what happens is that the first thing that the examiner wants you to do is that it's going to involve finding a certain term. All right. So your binomial expansion or your binomial theorem is going to be, you're going to be using it to find a certain term. How will you do that? Let's see. So, for example, one thing that is going to happen is that you, whenever you're going to be using your binomial theorem to find out a certain term, it is simply going to involve, your required power, oops, as well as your total power. And you're also going to be asked to, you may be asked to figure out a certain term itself. Like, for example, you may be asked to figure out, um, this is it, yeah. You may be asked to figure out, for example, the total number of terms as well, or anything of that sort can happen. Now, so what we're going to do, or what we're going to see for today is that, for example, let's dive directly into an example. So let's say that there was an example as in, I'll use an older example. I remember this one. 2 plus 3x raised to the power 8. And the question says, find the fifth term. Okay. Let's see what the question wants us to do. If the question is saying to find the fifth term, that means that one thing is for certain. What does that mean? If I want to find the fifth term, first I need to find the value of r. All right, I don't know R. Now, very simply, a lot of students will jump to the conclusion that R needs to be 5, right? Because it's the required power. But no, R over here is supposed to give you the required term. And one thing is for certain that whenever you're expanding, one term is without the power. Always. You can clearly see that there are always terms in an expression without the power. Therefore, if you want to find the fifth term, and one thing is for sure, okay, x plus 1 raised to the power 4, whole power 4 was expanded, and the 1, 2, 3, 4, fifth term was raised to the power 4. The fourth term was a power less than the total power. Therefore, if he is asking for the fifth term, that means that we're trying to calculate what? We want the power of that fifth term to be lesser than power of 5. So what do I mean is that we're simply going to go with, wait, let me make it a bit clean. So R is simply going to be, or how do you find your nth term technically, is going to be n minus whatever your, oh, apologies. R is going to be whatever your nth term is that you want to find, you subtract it from 1. Is this clear? So,
Yes.
so you're going to subtract it from 1. Therefore, in this question, R, you have to find the fifth term, right? So it's going to be 5 minus 1, which makes it equal to 4. First, you always remember for a binomial expansion question, finding out the values of n and r. N is easy. It's already like given in the question that it said. Finding out the other values of r are always very critical. Now I'm going to simply use my binomial expansion. So it's 2 plus 3x raised to the power 8. And judging from this, I already know that n is equal to 8. All right, now in order to find the fifth term, I need the power of the required variable. Technically, R is telling you what? R is the power of the variable. So on the fifth position, you're going to have a variable with the power of 4. That is why we're taking R as 4. So now what's going to happen? You're simply going to do 8C4, and the formula is A is 2 this time around, n minus R. So it's going to be 8 minus 4. Wait, let me zoom in. My 8 doesn't look visible. 8 minus 4. And then you've got 3x raised to the power R, which is 4. Okay, guys, solve this and let me know what's the answer. Yes, boys, what's the answer?
90720 x power 4.
90720 x raised to the power 4. Yes, that will be correct. Clear?
Not 4.
Yeah. Oh, sorry, 4. Apologies. All right. Now, one thing that you guys need to know is when x, when your variable, when x is equal to, or you can say is in B, the value of R is the power of x. All right, what do we mean by that? I'll tell you. Where am I saying that x is in B? When there is any term, like for example, it's supposed to be, if I use this example, it was 2 plus 3x raised to the power 8, which is being considered equal to a plus b raised to the power n. So always remember one thing, that when x, 3x or any x term is acting as b, clear guys? That means what does that mean? Is that the value of r is going to be the power of x. Obviously, because it's b ncr, a raised to the power n minus r and b raised to the power r. So if x is equal to b, then whatever the value of r is, that is also going to be the power of x. Clear? Is there anyone who does not understand this? Now, a lot of students, yes, any questions? Okay. Now, a lot of students don't get one thing, is that they seem to not understand why this happened. This. Why did we go through the hassle of trying to figure out what is the value of r? And that is also understandable to a sense that if you cannot understand it, let's go into it deeper. For binomial expansions, you're going to have particular terms. You're going to have term 1. You're going to have terms t1, t2, t3, t4, so on and so forth, up to you get like tn. These are your terms. And then you're going to have your powers of r. Always remember, you're going to always begin your required power of your variable from 0. Then it's going to be 1, 2, 3, so far and so forth. So you can clearly see that my powers of r are always receding the actual term number, because I'm beginning with 0. Obviously, one thing is going to have a 0 power, then power of 1, 2, 3, and stuff. Clear, guys? So therefore, it is always going to be, whenever you're trying to find an unknown term and you need to find the value of r, it is going to be n minus 1 is going to be there. All right. So you're going to have n minus 1 in order to find the power of r. Is this clear? Anyone who still does not understand this?
No, sir, I get it.
I think very easy. All right. There was one question more. Let's try to do that. It said, find the first 3 terms in the expansion of NCR. Oh, not NCR. In the expansion of, let's say, 9 minus 2x raised to the power 5. Now, this is where the examiner is going to be requesting expansion from you. All right, before it was finding out a particular term, now it's going to be expansion. And how you're going to do that? Let's see. So, one thing that you need to remember always is you are going to begin expansion of any binomial expression by 1. Oh, when r is equal to 0. So you're always going to begin expansion from r is equal to 0. Clear? You're always going to begin expansion from r is equal to 0. So now what's going to happen is that your expression says 9 minus 2x raised to the power 5, and then you're going to have subsequent powers of r. So you need the first three terms. So if I need the first three terms, I'm going to have what? I'm going to have r is equal to 0, because you always have to begin from 0. You're going to have r is equal to 1, and then you're going to have r is equal to 2. Clear? So you're going to have these three terms with you. And we already know from the question itself that n is equal to what you may call 5. Is this clear, guys?
Yes, sir.
Yes.
Now, simply again the formula. So it's going to be NCR, which is going to be 5C0 A raised to the power n minus r, which is going to be 5 minus 0 times b, which is okay. Should I take minus 2x or only 2x? Yes.
Could you repeat?
Should I take minus 2x as b or only 2x?
Minus 2x.
Obviously, the sign always travel. The sign is of the number, so it's going to travel with the number. Clear? So it's going to be 0. Okay, tell me the answer of this one, and then technically tell me the answer of all three of them. So this is going to be B5C1, 5 minus 1, minus 2x raised to the power 1, 5C2, 5 minus 2, minus 2x raised to the power 2. Tell me the three answers, guys, so that we can make a sequence.
You said the first one is 59,049.
59,049,
Yes.
049. Okay,
The second one is minus 65,610.
that's it. Like no X or anything. I
Yeah,
think it.
X.
Okay.
And um the other one is 29,160 x power 2.
29,160 x squared. So now how you're going to write it, because it's an expansion, you're simply going to say that 9 minus 2x raised to the power 5 expands to 59049 minus 656110 x plus 29160 x squared. All right. Also, one thing that you guys need to remember is a lot of questions will also involve over here. It was finding a certain term, right? In some questions, it will be finding a certain term, or you can say finding a certain coefficient. All right. So they could ask you for the coefficient of a term as well. Like, for example, they could say, what is the coefficient of x raised to the power 4? So you're simply going to say 90720. It's the coefficient of that term. Is this clear, guys? Is there anyone who does not get this?
No, sir, it's clear.
All right. Now, what's going to happen is that we're going to look into expansion of NCR. Now, this is a rare question. Normally, it doesn't really come, but it could. So let's not try to take any risks. So this is going to be the expansion of NCR. This is again not very common to come, but it can. Now we already know that NCR is equal to what? If I expand NCR, it is going to be n factorial over r factorial times n minus r factorial. So this is going to be NCR, which is going to be equal to n factorial over r factorial times n minus r factorial. Clear? And this rarely happens, like it doesn't really happen at that much, but it can. Also, if we were to describe what is n factorial is simply the multiplication of n times n minus 1 times n minus 2 and so on and so forth, n minus 3, all the preceding numbers of n, regardless of what n may be. So keeping this in mind, I can safely say that, for example, if it says NC0, oh, what if R is equal to 0? Then what's going to happen? So if R is equal to 0, obviously 0, and you're not going to be dividing anything by 0. So what is going to be the case? Oh, if what you may call, if it's 0, yes. What do you think is going to happen? 0 factorial multiplies with everything and stuff. It's going to always have, if it's, wait, I'll write it down like this so that you guys can understand better. NC0 is always going to be equal to 1. Is this clear, guys? And then what's going to happen is that now if we do NC1, that is going to be NC1 is going to be equal to M. And then what's going to happen? If we do NC2, that is going to expand as n times n minus 1 over 2 factorial. Is this clear, guys? This is the expansion of this with different powers of r. Similar is the case over here where you're going to have NC3. So you're simply going to have n times n minus 1 times n minus 2 over 3 factorial. And you could have it, continue forward as well. We can say NC4, more or less the same thing. You're just increasing the powers. 4 factorial. And this can continue on and on and on. Is this clear, guys? Anyone who does not understand this? Parthenople, is this clear?
No, sir, it's
Yes,
clear.
sir.
All right. Hmm. Okay, I'll solve the question with you guys. Let's see if you guys can do it. So, for example, it says 1 minus x over 3 whole squared. Oh, whole raised to the power n is the binomial expression. They are saying, given that the coefficient of x squared is equal to 4, find the positive values of n. All right, let's see. That's going to have find the positive values of n. Now, what do we mean by this? We are not disclosed what or by what power is this binomial expression expanding by. We are just told that if you expand it to a certain power of n, the coefficient of x or a term is going to become 4x squared. This squared term is going to have a coefficient of 4. How you're going to solve this one is pretty simple. Because my x is in the second term, like x is acting as b over here, I know for sure, just by looking at this, that if it's x squared, then that means r is equal to 2. And if r is equal to 2, then I can put in my formula. My formula says what? My formula is NC2 now, and it is going to have 1 times n minus 2 times minus x over 3 minus x over 3 raised to the power 2 or r, whatever it is going to be the case. So this is what, and this is equal to, we already know this as well, this is equal to 4x squared. This is what the question is telling us so far. Clear? Now what I can do is, because I don't have the value of n, there's no actual way to solve it. So I'm going to expand NCR. How am I going to expand NCR? That I'm going to expand this guy. And how will I expand this guy? NCR is written as, because it's raised to the power of, the power of r is 2. That means I can use this guy right here, which is n times n minus 1. So this is going to be written as n times n minus 1 over 2 factorial and you're simply going to have as 1 raised to the power n minus 2, and this entire thing is going to follow. You're going to have minus x over 3 raised to the power 2 is equal to 4x squared. All right, that is what you have expanded the entire thing to. Now we can solve it. How do we solve it? We're going to have this as n times n minus 1 is going to become what? N squared minus n. 1 raised to the power n minus 2 is going to be what? 1. So it doesn't really matter. So it's technically you're going to have this as 2, and this is going to be minus x over 3 whole squared is equal to 4x squared. That is what you're going to have. Now, if I expand this further, it is going to be um, n squared minus n over what you may call 2 times 9 is 18. The reason why I'm saying 2 times 9 because 3 whole squared is 9. Multiplied with 2, that becomes 18. And I'm going to leave x inside. I'm not going to open it up. The reason for that, I'll let you know as well. So it's going to just simply be x squared inside the bracket. I'm not multiplying x right now. So, and this is equal to 4x squared. Now, guys, this technique is also known as coefficient comparing. I hope you guys know what that is. So always remember, where did it go? That whenever you have this guy right here, you're going to simply compare coefficients because x squared is on both ends and you want to actually find the positive values of n. So, and on both cases, n is going to be a constant number. So technically n is acting as a coefficient to x. So this is known as comparing coefficients. All right, so it's going to be comparing coefficients. Now, if you compare coefficients, what are you going to have? This is going to look like 2u n squared minus n. You take all the constant terms with you is equal to 4. Okay, guys, if I solve this further, it's 18 times 4 is 72. So it's going to become n squared minus n is equal to 72, which is further going to look like n squared minus n minus 72. Solve this equation, guys. What do we get if we solve this equation? Tell me the two values of n. So n is going to have some sort of values. 2 in detail.
So I got 9 and minus 8.
You've got n is equal to 9 or minus 8. Now, what does the question says? Positive. So we cannot pick the other guy. Clear? So that is why this one's rejected. That it's not applicable. And this one will be your answer. Is this clear, guys? Is there anyone who does not get this? So, for example, if you are given a question in which you know this is a rare question, it doesn't occur that often, but it can. So, these are the types of questions that you can be asked. You can be asked to find a certain term or a coefficient. You can be asked to expand simple expansion. of an expression and stuff. Or you could be asked, you won't be asked directly, but you'll have to expand NCR to it. Is this clear, guys? Is there any question that anything that you guys don't get from this?
No, sir, clear.
All right. I'm going to give you guys three questions, and they are probably the hardest questions regarding this. So once you guys are done with this, done with those questions, then it's going to be easier for me because you guys will have done those. I always give them to my classes because these are the highest difficulty level questions regarding these chapters, especially the last two parts. Okay, wait. Kindly do them, guys. And this is five. And oh, one thing that students don't understand is this is a comma. This is not seven. This does not have any power. I'll just write it down separately. All right, guys. So where should I post them on Google Classroom or over here is fine?
Yeah, sure, on Google Classroom.
Okay, I do it on Google Classroom. Mm. Yeah, everything else is visible, right? There's nothing that you guys cannot understand. I'm just trying to make the brackets look better. If there's anything written that you guys don't get, ask me before I tell you guys to solve them. Okay. And how do I put this on Google Classroom? Should I just like take a screenshot of this and then post it there?
Yeah.
Right, I'll try to do that. Oh wow, it worked. Apparently, Google Classroom is not having it. Okay, I don't know what is happening to Google Classroom, but it's not letting me post it there. Should I like save an image? Yeah, I think I'll just save the image and then do it. Hmm. Hmm. All right, boys, I've sent it on Google Classroom. Kindly see to them and kindly begin doing these questions too. And you're officially done with binomial expansion. Now only questions. And in our next class, we will begin differentiation, and that will be done in a day or two, like the differentiation. And then I just need to finish integration, and P1 will be done. Then we will begin mechanics. All right, so you guys still have time in this class. Kindly begin working on your what you may call the question that I've sent on Google Classroom. All right, guys. So what you can do is you can complete these questions before our next class on Thursday, and there we'll discuss them. Okay, boys. Here's a new smiley for you guys. Have a
Yeah.
nice week. Allah Hafiz. Bye bye.
You too. So take care. Bye.